Question number 41. Which of the following indicated order is not correct? Okay. So option 1 it says the radii of Na plus is more than Mg2 plus is more than Al3 plus. This is correct, students. In isoelectronic species, as the cationic charge increases, the radii decreases. Okay. If we talk about the second option now, O is more than P in terms of electronegativity. This is a correct statement, students. If we talk about the third option now, F is more than Cl is more than Br is more than I. For electronegativity, this is also correct, students. If we talk about the fourth option now, it says that the ionization energy of O minus is greater than O positive. This is not correct, students. It is easier to ionize an anion as compared to a cation. So the fourth order is not correct, and for question number 41, we have to mark the correct answer as option 4. Let us look at the next question now. Question number 42. Consider the following processes. So process A has O2 converting into O2 plus. Process B has N2 converting into N2 plus, and process C has NO converting into NO plus. Okay. We have to select the processes in which the bond order increases. Okay. So if we talk about the process A, students, in the process A, the electron is removed from the antibonding orbital. So electron is removed from the antibonding. So it means that the bond order increases. If we talk about the second one now, N2 is converting into N2 plus, students. So in this case, the electron is removed from the bonding molecular orbital. So the bond order, it decreases. And if you talk about the last one, which is NO, so in the case of NO as well, the electron is removed from the anti-bonding orbital. So in this case as well, the bond order, it increases. Okay. So bond order increases in the process A and process C, students, and if you look at the options which are given to us, we have to mark the correct answer as option 3. Let us look at the next question now. Question number 43. Consider the following alpha amino acid. So we have been given arginine, lysine, glutamine, serine, methionine, tyrosine, tryptophan, and histidine. Okay. The examiner seems to be interested in those alpha amino acids which contain an aromatic ring. So if you look at the amino acids which are given to us, students, we can see that there is tyrosine, there is tryptophan, and then there is histidine. So these three amino acids, they contain the aromatic ring. Okay. So for question number 43, we have to mark the correct answer as option 4. Let us look at the next question now. Let us look at question number 44 now, students. Consider the following compounds. So we have been given 4 different compounds and we have to arrange them in the correct order of their basic strength. So students, if we talk about these 4 compounds, we can clearly see that Q has to be the least basic. So Q will be the least basic due to the ortho effect, students. Now if we compare S, R and P, so we have aniline, we have N-methyl aniline, and we have N-dimethyl aniline. So we know that N-dimethyl aniline is the most basic. So S will be the most basic, followed by R. So S is more basic than R, is more basic than P, is more basic than Q. So SRPQ, which is given correctly in the second option. So for question number 44, we have to mark the correct answer as option 2, students. Let us look at the next question now. Question number 45. Consider the following molecules. So we've been given 3 different Fischer representations and the examiner seems to be interested in the meso compound. Okay. So students, we can just apply the method of switches in this case. So we can switch this CH3 and H. So CH3 and H. Okay. And now we can switch this H and Br. Okay. So after 2 switches, students, the given compound, it comes out to be meso. It means that the original compound is also meso, students. So compound P is meso. Okay. Now if we talk about compound Q, students, we can clearly see that compound Q is not meso as there is no plane of symmetry. We can directly check for plane of symmetry in the Fischer representation containing 2 chiral carbons, students. So CH3 are symmetrical about the plane, whereas the H and the Br are not. So this is not meso. And if we talk about the compound R, students, we can also clearly see that this compound is also not meso. The H and the H are symmetric about the plane, but the CH3 and the Br are not. Okay. So out of these given compounds, only the first compound is meso, students. Only P. So for question number 45, we have to mark the correct answer as option 1. Let us look at the next question now.